the overview. We talked about the LLMs, then we also talked about the generative adversarial networks that mostly are used to create AI generated images. And now today we're doing more about RAG, and then we talk about agentic AI, not in depth though. I think I just wanted to cover like everything that there is. At least you guys will have, a general overview. And then now we can do our final project, which by the way I've decided we are going to do it individually, not as a group. And then now that's all. So today is just 10 slides. I think I had overestimated this part, but it's okay. So I hope you guys can see my screen. So what is RAG? We talked about large language models. So let's just talk about ChatGPT, because it's like, when I talk about LLMs, it's just ChatGPT. Everybody knows ChatGPT. So it has been trained on a lot of data, as we said yesterday. A lot of data. But now the problem was when, after you've trained with the data that you've already made the model learn from the data that you've trained it with. But then that's the thing about information, things keep on coming up, you know. So let's say I finished training my ChatGPT 2024, then 2025 Raila passes on. How will that AI know that Raila has passed on and it's 2025? The data that AI has, it's for 2024 backwards. So it was like a small challenge that maybe that researchers were able to figure out. When you train AI with the data, it is not up to date with current information, given that information happens every day. Every day there's something new coming up, and so on. So because it's a generative AI, what does it do? It starts hallucinating. It's going to tell you information. It was okay. Right now things are up to date because we have RAG, but then that's where I'm driving to. So if you ask an LLM current information that is not in the training data, it's going to hallucinate. It's going to answer you, but it's going to create its own information. It's because it's generative AI, it has to give something. So it's called hallucination. So RAG is a way of now, instead of now the model hallucinating, how can we make our model to be up to date with the current information without having to retrain the model? Because as I said, when you're training this large language model, they are hardware intensive, resources, hours, power. When I talk about resources, think of it even in terms of power. They consume a lot of power, by the way. And also then the GPU resources, data, and everything. So time is also a factor. So imagine having to retrain the model every time new information comes up. That's a lot of retraining, because we are human beings, always cooking things up, always having new things happening, and so on. So yeah, so RAG is like a way to make sure that our model retrieves the right information, which is current. And that's where it came up. That's why now we have RAG. And now people also found many uses of RAG, maybe in chatbots and so on. So we can just get into the definition of what is RAG. So RAG is retrieval augmented generation. It's a technique that enhances the capabilities of an LLM by incorporating information from external knowledge sources. So when we say external, it's because these are not the knowledge sources that we use to train the model, but now we're able to incorporate information. So it's like now LLM is able to get up-to-date information. So it reduces hallucination. As I've said, hallucination comes when the model does not know that information, so it's going to cook its own answer. So it reduces hallucinations by grounding outputs into grounding outputs in external knowledge. So basically, RAG enables LLM to stay up to date with new information without requiring constant retraining of the base model. But how does it do this? Let's say we have our LLM. Let me just draw, we have our LLM. Then we have new information here, you know. So we talked about generative AI, and you said they generate us of prompts. They what you've asked, you have to ask something for AI to answer you, you know, that relationship. So I have a prompt here. I have a prompt about current thing that is happening. And this current thing, maybe it's in this database. Maybe there's a live database. Let's say this website, let's say blogs, anything that has new information. Maybe that's online, or maybe that's anything that has new information about your organization. Some are maybe organization specific. So I have my prompt here, and I have my new data here, and my prompt is about my new data. So instead of this LLM hallucinating, RAG retrieves information from this database, and then LLM here now, it's used for now generating the information, but it's going to still generate information, but now it's going to base that information on these facts, the new information, the new data that the prompt is asking. I don't know if I'm explaining well, but that's the context. Now I'll get my answer here, my output, which are contain facts that have been retrieved from this database and generated by the LLM, and that is what we call RAG. So yeah, but I think the next slide has a more visual explanation for that. So it enables domain-specific AI also. As I've said, now people have leveraged RAGs in creating chatbots, because I can create a chatbot that retrieves information only for maybe from my organization's database, or maybe if you have like an internet, or maybe they are called document management systems. So that is specific for that organization. So it's going to access database that is only for that organization. So people have found a lot of ways in which now we can create AI chatbots using RAG, and maybe retrieve information using RAG without actually, if you have like your own information that you want to use it for RAG. Yeah, it's widely used in enterprise AI chatbot. It's like the new, it's not new honestly, but it's like this technology that has been nowadays being used for chatbots and assistants to help them provide more accurate and personalized support, e.g., by accessing frequently asked question, customer history, product information, and so forth. So if you have a business that has a live database and you're using RAG on it, it means that you're able to retrieve the most recent information possible. Maybe if it's a chatbot and so on. So it has found a lot of users nowadays, and it's a good, technology. So this is a more detailed explanation of RAG. So I have a document here. Then, okay, this is a way that RAG works. It splits information into chunks. So I think chunk is a hyperparameter. I don't think it is a hyperparameter. You can set chunks. You can set how many information chunks will be, how your information will be splitted into how many chunks. If you want 150 words per chunk or 200 words per chunk and so on. But still, even if it's doing all that, still the process of turning that information into tokens, embedding, etc., feeding it in a way that a machine understands, it still takes place. It's still part of the process. Don't forget that. And then now we augment. This is retrieving from here, from these documents. We augment, we pass it through an LLM, we get our answer. So this is like a visual presentation of RAG. But this is where the work is. Don't forget, we have information. We still have to split it. We have to do embedding. We have to do all those vectorizations, etc. And now LLMs and etc. But now, how do we do all this information? How are we connecting our LLMs to my document? We have our data here, and now we have our LLM here. How are we connecting that information? So we're accessing our LLMs using API calls. We have a lot of ways, but API calls is one of it. I won't explain too much about APIs, but I can just explain what an API is. Let's say I have two, I think it's called application something interface. Application. I don't know what P stands for, honestly, but interface. So, okay, I don't remember. So what does API do? I want to call them softwares. Let's say two different applications. So application 1 here, application 2 here. But now, maybe I need to retrieve information from application 1 for application 2. But these are two different applications. So an API is like something that is able to actually make a connection between two different applications. When I talk about application, could be from a website, from an app, from a web app, etc. So making an API call enables you to retrieve maybe the information that you want from an application that is separate from the one that you're doing. So it's like an interface of connecting two different applications. So we make an API call to our LLM, and that's how we access LLM in our situation. That's how our document is connecting to an LLM. So I don't know if you guys have understood the whole concept, or have I used a lot of wordings? Are we together? Any question? Are we together, guys?
Yes.
Okay. So we have LangChain. It's an open source framework that does now this API calls now, this part for RAG. So it does that. So it's an open source, which means it's open there, accessible for everyone, anybody. You can use it anytime, anyhow. It's open source for building applications powered by LLMs. So LangChain was launched in 2022 by Harrison and Ankush, and it provides tools, APIs, and abstractions to connect LLMs with external data sources, maybe databases, APIs, etc., memory, tools and agents, etc. So it's like it enables you to communicate to an LLM, So it enables the RAG process, it makes the RAG process easier. These are the key features of LangChain. We have the modular component, the first. LangChain's modular design simplifies development, enabling effortless application building and experimentation. It enables integration with external data sources. It's good for prompt engineering because still prompt engineering plays a critical role. When I'm doing my prompt here, it's still prompt engineering. It's still, they am accessing, they are making my LLM generate information. It's still prompt engineering. That's what I'm trying to say. It plays a key role in this situation in RAG. Memory capability, it remembers conversation. That's why it's easy to create chatbots with this LangChain and RAG technology. Enables RAG, you know and also deployment and monitoring. So we have Langsmith and Langserve that simplify debugging, testing, monitoring, and deployment of applications. So it's a framework on its own. So you can go to LangChain documentation and learn more about LangChain if you want to do more about, LLMs, RAG, chatbots, AI automations, etc. It's a good tool for that. This is just a simple visual representation of the whole process. So, we have our this is our LLM here, you know. Then this is LangChain, how it integrates with our prompt, which is here. So these are just Streamlit is just when you're building a small chatbot, let's say a small chatbot, you can use Streamlit to view it front end. So it gives you that UI, that interface, that user interface that you can just run and maybe see how your chatbot is going um to look like, Yeah, so it enables that prototyping part, and you can also use it for projects, and it's useful. But now this is how we have our open AI. Now our LangChain is connecting us to our maybe external memory and everything. We are retrieving information from this external source, then we're using LLM to generate, then we have our input prompt, then we have our output. This is just a small visual, a slide to help us understand the process. So any question on RAG and LangChain? Are we together on that? I'm going to assume that we are together. So our other subtopic is agentic AI. I think by the start of this year, this thing was trending. Agentic AI, everybody's creating their own AI agents, etc., and so on. I think the interesting thing about AI, it's evolving. So being in the field of AI also calls for you to be more proactive in learning what's new in the market. Okay, don't overwhelm yourself also, because I get that process of when everything seems to be advancing every day, there's the need for you to keep yourself updated. Don't overwhelm yourself, but also knowing what's really happening is going to help you stay on top of the chain of the food chain. And also there's a lot of research, a lot of funding going to AI. So of course, being that in that field is expecting new things to come up, you know. So agentic AI refers to an AI system that can act autonomously to achieve specific goals. So think of it like this way. For example, when I have a chatbot, it's more of reactive. It's responding to my prompt. It's giving me response according to how I have prompted it and so on. But now agentic AI is more proactive. It's able to do things on its own. It's not reactive, it's more of proactive, think of it that way. So it works with actually minimal human intervention. Unlike traditional AI that reacts to inputs, agentic AI is proactive, planning, adapting its behavior to achieve desired outputs. And it is considered to be the next step in AI development, moving beyond simply responding to prompts to actively pursuing objectives. So, yeah, so this slide is just a general overview of what agentic AI is. Um, this is a small visual presentation. We are still in LLM, we're still in generative AI space still, but now we have agentic AI. So nowadays, people can build AI agents that can make their work easier. We also have a lot of tutorials out there that can help you build an AI agent. So I think that was all about the content. I just wanted to make sure that I cover as much as possible for the bootcamp. So any question, guys?
I have a question.
Yes.
In agentic AI, are they only used procedures that are recurrent, like procedures that are known. You have to do step one, two, three in that manner.
Not really, because the thing about AI, it's beyond traditional machine learning. It's, let's say, think of AI as something that easily adapts, the adaptive nature of AI generally. So yes, there's the part that, okay, you have asked if it's specifically for things that repeat. I think I'll just say, think of AI as something that adapts, you know so it's not limited to those things that are repetitive and so on. Have I answered your question?
Yes, but
But
how do they?
it can be used, yes, for repetitive tasks. I think that's where AI automation comes in, because for us, we want to use AI for automating things, for making work easier. Let's say, for example, if I work in a call center and I get a lot of calls, I want to use AI to deal with as many calls as possible. If I'm working in a customer centric environment where we have a lot of things that we do all the time, I want to automate that. So yes, it is used on repetitive tasks, but no, don't limit it to that. Are we together?
Yes. So
Eh,
is that for?
mhm.
Does that go for agentic AI as well?
Yeah, yeah.
Okay. Thank you.
You're welcome. Any other question? So if you have any question, can just ask. I think we can have a discussion today on the questions that you guys have. Mm, So we have a small practical project, the final project, that I have decided that we are going to do it individually, because it's still guided. So there's no need of doing a guided project as a group. You guys are not going to learn as much. So doing it individually is much better. So it's on RAG. We're going to also do more on generate embeddings and store in files, generate question answering. We're going to use LangChain. Um, so this is the assignment. You'll apply your understanding on generative AI and RAG to build a practical pipeline that retrieves relevant document chunks and generates context-aware answers. So this basically it's it. I'm going to share this. I think I shared this slide yesterday, and then to share the assignment. So when I'm reviewing the learning outcomes for this class that started yesterday, we're able to define generative AI, its core principles. We have already distinguished it from traditional LLMs. We have learned more about evolution of generative AI, even learned more about LLMs, the current, and also small models, small language models. We have explained several concepts. We have learned about prompt engineering. We are able to this now. We're going to implement it over the weekend. And also now, that's all. That's it, actually. I think today's class is the shortest, actually. I realized I didn't have like a lot, because this was my last slide share. Yeah. So I think I'm just open to like questions, discussions, any observation. So we can take the next 30 minutes to maybe learn from each other, and then yeah, that's all for today. So any question, anything, I think anything that now that cuts across the whole course. Don't limit yourself to today's class also.